Hey there, Mr. Sutton here, bringing you the Pre-Cal Honors 4-4 Extra Practice Number 2 solutions on rules of logarithms. There's a puzzle that goes with this. Let's go ahead and take a look at it. So here's our puzzle. We're trying to solve the riddle, what do you call a person who likes to blow up bars? Sounds kind of violent. So the idea here is that we've got a bunch of logarithmic expressions that they want us to combine into a single logarithm. And then match it with one of the expressions over here on the right. Whatever letter that is, we're just going to put that letter above the appropriate number down below. So if I do number 1, for example, and the answer is this A right here, I would put an A above this 1 here. I don't know if that is the answer. I guess we'll find out. So let's dig a little deeper into this one and see what we get. For this first problem, we've got 5 log base 3 of x plus 7 log of y. First thing I'm going to do here is I'm going to move this 5 and this 7 into the logarithm using my pop-in rule, where I can turn a coefficient into an exponent. So I'm going to rewrite this first piece as log base 3 of x to the 5th. And here I'm going to have plus log base 3 of y to the 7th. Next, if I have addition of logs like I have here, I can multiply the things inside of them and turn it into one log. So this is going to be log base 3 of x to the 5th times y to the 7th. And I can match that up with this O right here, so I'm going to put an O in spot 1. For this next problem, we've got some subtraction going on. Before I worry about that, though, let me move my coefficients in as exponents with my pop-in rule. So we have log of x to the 6th. This is going to be minus log of y to the 4th. And then we'll have minus log of z squared. Now, for these negative logarithms, subtracting a logarithm basically means dividing by whatever's inside if you move it all into one big logarithm. So my log of x to the 6th, that's going to stay in the numerator. But now the things that I'm subtracting, this y to the 4th and this z squared, those are each going to move into my denominator like I just did there. So anything that's being subtracted goes into the denominator. And I can find that answer, let's see, that's going to be E. So E goes on spot 2. For this next problem, we have a 3 outside of parentheses with some logs being subtracted inside. Now there's a few ways to approach this problem. You could do this from the inside out, pop the 4 in, move this together into one big log using division, and then apply the 3 as an exponent on everything. Or you can do what I did, which is to start on the outside and distribute this 3 and then pick up the pieces after you've done that. So if I distribute the 3 first, I've got 3 log base 3 of x minus 12 log base 3 of y. And now I don't have to move exponents back and forth. I can just do it once. I'll move this 3 in to get an x cubed, and I'll move this 12 in to get a y to the 12th. At this point, I just have basic subtraction of logs, so I can move the x cubed and the y to the 12th into a fraction. This will be log base 3 of x cubed divided by y to the 12th. And there's nothing else I can do to simplify this. So let me pick that answer choice. That's going to be A right here. So that's going under blank 3. For this problem, I have log of 1 over x, which is kind of weird, plus 4 log of x. So I'm going to simplify the things inside my logs first before I do anything else. I'm going to rewrite this first expression as log of x to the negative 1, because that's what negative 1 does. It gives you this reciprocal here. And I'm going to pop this 4 in as an exponent on that other log, so log of x to the 4th. Now that I'm adding these logs, I can just multiply the things that are inside together. So I'm going to have log of x to the negative 1 times x to the 4th. That means I'm going to be adding those exponents to get x cubed inside my log. And then x cubed, log of that, that's going to be right here, spot L. So let me put an L above the 4. For number 5, I've got 20 log 5th root of x. I'm going to rewrite this root as an exponent just to make it a little easier to deal with. So the 5th root is really the same as the 1/5 power. And now I can pop this 20 out here in as an exponent on this. if I have x to the 1/5 to the 20th, I'm going to be multiplying those exponents. So 1/5 times 20, that's going to give me 4. So I have log of x to the 4th. And I see that down here for choice R, so that's what 5 is. R. For number 6, let's deal with this expression. I'll start this one by popping this 3 in as an exponent. So this is log base 3 of x to the 3rd. And then for this next one, I could rewrite this as y to the -1, but if I were to pop that out as a coefficient, I'd be popping out a -1 here. That would make this a positive. So I can actually rewrite this whole second term as plus log of y. And then if I add these logs together, I am just multiplying the things inside. So this is log base 3 of x cubed y. And x cubed y, that's going to be right up here, very first option, an n. So we'll put that on spot 6. Here we go with number 7. This one's going to end up needing a lot of work. I'm going to start the process by popping all of these coefficients in as exponents. So we have log of x to the 1/2 plus log of y to the 3/2 minus log z to the 2. All right, next thing I'm going to do to make these a little bit easier to combine, I'm going to take these halves sort of exponents and turn those into radicals. Dividing by 2 in the exponent is really the same as taking the square root. So this first one I'm going to call log of square root of x. This next one I'm going to have plus the log of square root of y cubed, since we have a 3 in the numerator of that exponent. And then this last one can stay the same. Now moving these together, since I'm adding these logs, I'm going to be multiplying the radical x and the radical y cubed. Those are going to end up inside one big radical, and that's all going to be in the numerator of a fraction. Since I'm subtracting log of z squared, that means I'm actually dividing by z squared when I merge all these together. So I'll put the z squared down there. Now this doesn't quite match any of the answer choices, so we're going to simplify this radical upstairs a little bit more. I could split this y cubed up into y squared times y, and then the square root of one of those y squareds is just going to be a y coming on the outside here. So when the dust settles, I have log of y radical xy over z squared, which matches choice O, and that's going on spot number 7. This next problem is a little bit intense. We have parentheses, 2 parentheses, lots of logs, different variables, subtraction, pretty much everything that can go wrong in one problem. I'm going to start this by distributing these 2 outside coefficients to the parentheses to make things a little bit less stuck together. So for this first one, I'm going to have 6 log base 3 of x minus 12 log base 3 of y. For the next one, I've got 10 log base 3 of y minus 2 log base 3 of x. Next thing I'll do, I would put these coefficients in as exponents, but one thing I'm noticing here is that I have multiple logs that have the same thing inside of them. Like we have this 6 log base 3 of x and this -2 log base 3 of x. So those are actually like terms. I can combine those like terms. This is like having 6x minus 2x. So I end up with a 4 log base 3 of x if I combine those. And these log base 3 of y's in the middle, -12 plus 10 gives me -2 log base 3 of y. So that's looking a lot nicer. I'm going to go a step further and pop in the remaining coefficients here. So we have log base 3 of x to the 4th minus log base 3 of y squared. And then finally with subtraction, I will move these logs together by dividing the things inside. So this will be log base 3 of x to the 4th divided by y squared. And after all of that, I can confidently pick answer choice A right here. So that's going in spot 8. For number 9, we have this -2 times a parentheses with some logs in it to deal with. I'm going to deal with that actually right away. So I'm going to distribute this -2. So we'll have log base 3 of x minus 2 log base 3 of y minus 6 log base 3 of x. Next up, let me check to see if I have any like terms I can combine before I use real log rules. Looks like we have a log base 3 of x and a negative 6 log base 3 of x that I can combine. That'll give me negative 5 log base 3 of x minus the 2 log base 3 of y. Next up, let me move some of these coefficients in as exponents. So I'll pop in that whole negative 5 to get log base 3 of x to the negative 5th. And I'll pop this 2 in as well. I'll leave the subtraction there for now, though. So this will be log base 3 of y squared. All right, moving all these together, we're going to have subtraction, so that's going to be division. I'll have x to the negative 5th divided by y squared inside one big log. But x to the negative 5th, I can simplify that by moving x downstairs and making the exponent positive. So when the dust settles, I have a 1 over x to the positive 5th from this negative 5th right here that I'm simplifying. And I'm also going to have a y squared down there because I'm dividing by the y squared if I'm subtracting the log that has it. So 1 over all that stuff, I see that in choice M. So that's going to be in spot 9. All right, things just went nuclear real fast with this problem here. This is kind of crazy looking. So there's a lot of ways you can deal with this. I think since I'm adding these logs, though, I'm just going to move everything in together right off the bat by multiplying the things inside. So I'll be multiplying two fractions together. So numerator times numerator, denominator times denominator. So I'm going to have log of x squared times x plus 1 in that numerator. And for the denominator, I'm going to have the x here. And I could write parentheses x squared minus 1, but I actually think I would be benefited by factoring this so that I could cancel out something up here. So x squared minus 1, I can split that up into x plus 1 and x minus 1. That's just a difference of squares there. And I see right away that I can now cancel out some things. The x squared and the x can cancel, leaving me with just an x in the numerator. And the x plus 1s can also cancel. So when the dust settles, I end up with log of just x over x minus 1. And that answer choice is right here, choice O. So 10 is O. For number 11, I've got subtraction of two logarithms. The expressions inside are kind of crazy, but I can just merge these together by dividing those two expressions. So log of x squared plus 2x plus 1 over x squared minus 1. I can go a little bit further with this one. This is none of the answer choices, even though it's a single logarithm, so that means I must be able to simplify the stuff inside. Let me factor and see if I can cancel things out. So for my numerator, things that multiply to 1 and add up to 2, that would be 1 and 1, both positive. So x plus 1 and x plus 1, or x plus 1 squared if you like. And then x squared minus 1, we actually just did this on the last problem. That's x plus 1 and x minus 1 still. It looks like one of these x plus 1s can cancel, so that leaves me with log of x plus 1 over x minus 1. And that's answer choice B right up here. So that goes in spot 11. Now, got to be careful because there's another 11 actually, so we use that one twice. Now for the final boss battle, and this one is truly deserving of that title. This is just nuts here. We've got nested parentheses, all subtraction. Factoring is probably going to be needed, just craziness. Let me start by distributing this negative that's outside of this big parentheses, just so I don't get any sign mistakes along the way. So I've got log of x plus 2 minus log of x squared minus 4 plus, because I'm doing minus minus, so plus log of all that stuff over there. Now let me move all these together into one big logarithm. Anything being subtracted, that stuff inside ends up in the denominator. Anything that has a positive out in front, that ends up in the numerator. So I end up with a log of x plus 2. That whole thing's positive, so x plus 2 is upstairs. And we also have a positive log over here, so the x squared minus x minus 2 ends up in the numerator as well. And then it's just this x squared minus 4 going downstairs because that's a negative log. I think I can factor this now. Let's try factoring. So I have the x plus 2 that was there already, and now I need things that multiply to negative 2 and add up to negative 1. Well, positive 1 and negative 2 will do that. So x plus 1, x minus 2. And downstairs we have the difference of squares. I can square root and use a plus minus with that. So I'm going to have x plus the square root of 4, so x plus 2, and x minus 2. Does anything cancel? These x plus 2's do for sure, and then the x minus 2's as well. So all that's left at the end of this one is just log of x plus 1, which I would say is much simpler looking. And that is going to be right here, choice S, so that goes in spot 12. So at this point, we're ready to solve the puzzle, which again was, what do you call a person who likes to blow up bars? And that would be a saloon-a-bomber. Now, this is a little bit of a play on words, or kind of a rhymey play on words. Back about 30 years ago, when this joke was probably written, there was an individual who became known as the Unabomber, who sent people envelopes with explosives in them, all sorts of nasty stuff. So this is kind of a joke, I guess, referencing the Unabomber back in the day. Not sure if that's really the best kind of humor, but hey, it's the solution to our puzzle, so there we are. Till next time, Mr. Sutton signing off.